If you look at history, innovation doesn't come just from giving people incentives. It comes from creating environments where their ideas can connect. With these words from Steven Johnson, I, Rana Randeep, from Mechanical Engineering Department of Batch 2K20.
And I, Manisha Kumari, from the Department of Mechanical Engineering Batch 2K20, greet you all a very warm good morning. With full energy, I would like to welcome our chief guest, Dean Academics Dr. Pankaj Rai sir, Head of Department Dr. S.K. Singh sir, our guest speaker, and all the other professors and participants present over here in the last day of online faculty development program conducted by the Department of Mechanical Engineering, BIT SINDRI.
Now, moving ahead, today we have Kumar Saurav sir as our eminent speaker. But before beginning his session, I request you all to please follow some basic guidelines during the session to make it more interactive and for its smooth running. We request you to use the chat box as much as possible for your queries. Jot down your queries there and we will take that at the end. In case if it is urgent, you can raise your hand and we will unmute you. Thank you for your cooperation and patience. Stay connected till the end of this session and enjoy.
Kumar Saurav sir is currently a business process manager at Nordex, which is a renowned wind turbine manufacturer. He has worked with Airbus before and had published a paper called Technology Road Mapping for a single SL aircraft of Airbus. Today, this is the topic on which he would like to present. The talks about how any company can connect the market requirements with the technology present in the company. With these, I would like to call Sir to share his insights over here on the topic road mapping of aerospace technology. Sir, please carry on.
Hi everyone, thank you very much. So first of all, a very warm welcome over to my topic. And yeah, I'm very much honored to actually be brought over here. And I will actually share my screen now so that you can actually, like, just give me a second. Please let me know if you can see it.
Yes, sir. It is
Okay,
visible.
thank you very much. So, this would be my topic for today, the technology roadmap for the single AL program of a major company in aircraft industry. So basically, like this would be the organization I would be talking about, Airbus. So I think like you must have heard about Airbus a lot. So it is one of the biggest manufacturers of the aircraft in currently. So along with Boeing, it actually forms a very big market for the aircraft industry. So, so basically, what we'd be talking about is a methodology which we call as technology road mapping. But before that, like, what are we actually going to talk about? Like, we will start with like a very short introduction to the organization. What is the problem that we are actually dealing with, so that like we can actually understand why exactly do we need technology road mapping, and how we can actually develop this particular methodology, and be it any kind of an industry, we can actually use this methodology quite well. So let us begin actually. So a very short introduction to the organization. If you have basically flown in an Indigo or a SpiceJet, any kind of an aircraft which is operating inside India, then basically it is a single aisle. So single aisle, what does a single aisle basically means is that if you have actually entered inside an aircraft, then you will see only one row. There, if you go inside an international airline, there would be two rows actually. So basically, a three-seated arrangement on one side and a three-seated arrangement on the other side. That would be like a single aisle. So you can walk actually inside the aircraft only on one lane. That would be your single aisle aircrafts. So talking about Airbus, like it is one of the largest commercial aircraft manufacturers. It is a worldwide actually leader for A320. By A320, what I mean, like there are different kinds of models actually, like A320, A330, A340. So these are the kind of products that we see inside Airbus. A320, what you see on the very first left hand side, like it is a single aisle aircraft. So Airbus also like makes corporate jets, and as of like financial year 2024, and manufacturing facilities for this particular organization is actually in France, Germany, Spain, China, and the UK. In India, there are also facilities, but they are not manufacturing facilities. They are R&D facilities. So basically, whatever works you see in CATIA or designing activities, they go to Airbus Bangalore. And rest of the manufacturing facilities are available in France, Germany, Spain. So where I am currently located, like the place is actually called Hamburg, and in Hamburg, the assembly activity actually happens. So you will see a lot of parts actually coming in from different regions of Europe, like France. They will be coming from Spain, from the UK. So different parts of the aircraft, like the nose of the aircraft, the main body of the aircraft, the tail of the aircraft, everything would be coming to Hamburg, and they will get assembled together. So why do I actually talk about only about the single aisle? Basically, single aisle is one of the oldest and the most successful aircraft program. And Airbus is actually having 75% of its revenue actually coming from single aisle. So whenever you see an aircraft like Indigo or SpiceJet, well, most of the time, like there is a major possibility that the aircraft was actually from Airbus. So that makes it one of the most successful aircraft programs. So if you see just a small number, like in 2021, 20,345 aircrafts were actually ordered, and out of those, actually 16,000, more than 16,000 actually, they belong to single aisle. So you can just imagine the sheer number of aircrafts which belong to the single aisle, like out of the total number of aircrafts. So it is a big number that actually single aisle actually receives. So like why exactly I brought up this topic of single aisle, like inside the research paper that was actually published. Basically, the thing is, like if you understand that, like if any big organization is there, the change management inside the organization is also very, very difficult. The thing is, because it's a kind of a legacy program, it is a very old aircraft. A320s, they have been actually been developed in such a long amount of time. Therefore, the adaptation to new technologies is very slow. So basically, you will understand, say, for example, there is any company or any university which is there, which is actually existing since a long amount of time. Therefore, like to bring in new kinds of changes inside any organization, it's a little bit difficult. Then the second thing is that what I've written as like focusing more on the production ramp up. So one other reason is that like we saw that like in the last few years, the demand from the Asian side was very, very high. Say, for example, the population inside India, they require a lot of other transport means. So, like there are a lot of bookings actually going on. So there was a lot of requirement from the customer end. Say, for example, Indigo or SpiceJet, they said that like, hey, Airbus, we need a lot of more number of aircrafts. So basically, in order to actually do that, there needs to be a production ramp up. So therefore, like we need to increase the production. So how can we actually achieve that? The third thing is what I wrote it as like new aircrafts equipped with modern technologies, but no skill transfer to single aisle. So if I talk about like the other aircrafts which are existing like A330 or A340, which actually fly international, they are quite modern. So as to say, they are equipped with modern kinds of technologies. There is predictive maintenance. There are a lot of other things which are actually available to the new aircrafts, but there is no single skill transfer to the single aisle because as I said earlier, this aircraft has been running from a long amount of time. So these kind of have like old technologies. The fourth is like many customer requirements and maintenance. So like there, as I was talking about predictive maintenance, like there are a lot of requirements from the customer side as well, which go unmet. There are a lot of accidents which happen, like when basically the aircraft is getting parked. So like you might not know, but actually a lot of aircrafts face a lot of problem when they are actually parking themselves inside the airport. So like there are a lot of scratches which actually come in. So these kind of all those things are there. And the last point is that like the competition which is coming from Boeing. So Boeing is our biggest competitor from the United States. And there are other mid-sized manufacturers as well, like Bombardier. But like one business side of Bombardier, Airbus bought it from Canada. So therefore, like so this is the current competition setting that you are seeing. So basically, if you want to survive in the this competitive environment, you need to also think about of new kinds of technologies, or you need to think of new business models, how to operate. So as you see, so basically this particular graph will actually tell you something. Is that if you see in 2004 in Europe, or like let's consider like emerging countries itself, it will give a much better idea. So if you see the number of the aircraft which were actually demanded were 1,120. This was in 2004. 2014, this particular number, like this gray shade, what you are seeing is like from emerging countries. So from 1,120, it went to 2,000. From 2,000 in 2024, we are expecting like 2,936. And then like so basically like 3,977. So basically you can see that like the numbers are basically increasing. And what we see over here is like this particular timeline, what you see on the bottom is basically showing you the world population in millions. So basically you can see the world population is increasing, the demand is actually increasing, and we basically what we actually understand is that the middle class, which is basically there in the Asian side, that is doubling in the emerging countries. So people are willing to actually like travel more inside aircrafts. So basically that means that there will be a lot more demand on the Airbus side or any other aircraft manufacturer, and because of that there needs to be a lot of production as well. So that's why I was telling you that why do we actually need such kind of technologies, or how we can actually reach that kind of production level. So like why do we exactly need technology road mapping then? So basically we need technology road mapping because we need a kind of a project plan, like how we can exactly have a kind of a holistic plan which basically combines what the technology is available inside our organization, what are our resources, how we can combine each and everything together and bring up kind of a project plan. It's just like, say for example, you are going to a supermarket and you are trying to get things, so you will write it down on a piece of paper saying that like we need this kind of groceries, and then we need to go to the supermarket. So now this technology road mapping is a very similar thing, but there is a different methodology. We will use some kind of analytical tools as well inside. So the first thing what we need to understand is like a business concept. What we use inside technology road mapping is a SWOT analysis. What is a SWOT analysis basically? So SWOT analysis basically talks about the strength, weakness, opportunities, and threats. So this is a kind of a 4-box report that we create. Like we what we talk about is what are the strengths of the organization, what are the weak points of the organization, what all are the opportunities that actually the company can actually see in the coming days, and threats basically talks about what all are the problems actually existing and what is the competition that we will see. So these are the kind of tools that we actually see right at the beginning to actually analyze our market competition and then also see our weaknesses and strengths. So, but there is a problem again with this kind of a tool that we see. Like there are very little reference to the technologies, what you see over here. So it's like it talks a lot about business concepts, but one of the things inside any particular technology company is that you're not even talking about the technology. So therefore, like we need a tool which actually talks not only about like the business concept, but how we can actually combine this business concept with our technologies inside our organization. So then basically our roadmaps basically help us to actually have a better coordination between the business activities that we have and the resources that are actually existing inside the company. So basically, so this is something which we actually do, and which I also did for Airbus. So one, we have like different kinds of workshops that we actually hold inside like inside the organization, and then like in each particular workshop we actually carry out a lot of activities. So for example, The first workshop that we actually deal with talks a lot about market, like how we can actually combine our performance, like how we can actually combine our performance with our market. Then we also perform the SWOT analysis, what I actually told you, like strength, weakness, opportunities, and threats. Then we see what all are the gaps actually existing between in the between the market drivers. And then we also see we actually evaluate our product, like what all are the products actually available inside the organization. We do a ranking of these particular products. Then we talk about technology, what all are the technology solutions. Then the final thing which it comes in is road mapping. Now, the main question arises, like how do we combine all of these four particular things? Because we are doing a lot of workshops, but what is the end product? So that we will actually discuss about in the coming slides as well. So this is the research methodology that was actually followed. So first of all, you do a market and business driver identification. So what do I exactly mean by this? So market and business driver means, say for example, one of the core concepts that is actually we are talking about today is about sustainability. Now you are seeing a lot of climate change. You are seeing a lot of actually disasters, actually worldwide disasters actually happening. So one of the core things for any organization would be sustainability. How we can actually reduce the amount of carbon dioxide that is being released in the environment. What we can actually do. So these are kind of business drivers which the company identifies. Now, whenever you go into any organization, for every particular year, they have a yearly plan. So they will say that like these are our 5 particular goals that we will actually focus on. So the thing is, the technology roadmap actually also includes these particular 5 drivers inside our planning. So what we do is that first, like there is a market and business driver identification, why we identify what all our core goals for this particular year, or like for the coming 5 or 7 years. Then we actually see what all are our product features, like we will talk about in the coming slides, like what it is exactly. Then we do a gap identification. Then after that, we develop a matrix. We will develop a matrix to actually evaluate how are these market and business drivers actually connected with these particular product features. And then we will actually compare both of these particular things using a quality function deployment, which I wrote it as QFD. Again, we will actually talk about technology features, we will actually talk about the technology features which are available for the particular product. And then we will see, we will actually make a matrix between these particular product features and the technologies using again the quality function deployment. So what I'm actually trying to show to you over here is that every stage, like starting from the beginning, whenever we are moving to a new kind of a feature, like we are actually doing a quality function deploying. So it's like, say for example, there are 4 particular stages like A, B, C, and D. So first of all, we will develop a matrix between A and B. Then again, we will actually develop a matrix between B and C. And then we will again develop a matrix between C and D. So in that way, we can actually identify what all are the connections between A, B, B, C, and C, D. So it's like doing a kind of a matrix evaluation and seeing what is really, really essential and how we can actually connect everything together. And then after we have actually developed this particular matrix between the product features and technologies, we will actually list out the resources which are required for realizing these technologies. And then the final thing which comes in is a roadmap. So going a little bit deep inside, like into the topic. So I was talking about the first stage. The first stage was like what all our market and business drivers. And this is a kind of a methodology which you can use also in your research as well, very, very well. Is that what you do is that first of all, you need to understand what does your research exactly requires. So first of all, what is the driving point? So for example, for Airbus, there were quite a number of drivers which were actually existing. So say for example, the end customer experience. So what do I mean by end customer experience? You can find the definition over here. Is like the in-flight experience of the customers using latest technologies, including seat design. So whenever you enter inside the aircraft, you will actually, you sometimes you see that like, oh, Indigo has actually switched on a certain kind of a color inside, or like they are having a different innovative design. So that way we can actually see that like it's a driver for us. So basically it is the experience that the end customer, which is basically you are experiencing. What are you experiencing inside the aircraft? The second thing could be support for the technicians. So the technicians basically, say for example, if you have been to the Ranchi airport, like you will see that like at times when basically the aircraft has actually parked itself, there will be some technicians who actually come to the aircraft. They check on to different kinds of technical things, like if the fuel meter is right or not, if the amount of pressure that is required inside the aircraft it is sufficient or not. So these kind of needs which are actually called as drivers, and these kind of drivers basically we can categorize it. We can say that, yeah, like the technicians can also be called as customers for us, because they are the end people who would be using these technologies and they will be helping out the aircraft. So we can also name them as customers. So then we actually put some codes inside it, like D1 or D2. And why we actually do this is that at the end, when you are developing a roadmap, you cannot actually write this whole drivers inside. So basically, if you put some kind of codes inside them, you can actually identify them like quite easily. Then basically there are weights. On the right hand side you can see weights. So what are these weights? The weight means that you are giving some kind of a weightage to these particular factors. So it ranges from 1 till 10, and you can see the third one is like, we can say that like it's a bit low, so the weight is not that very high. If you see on this particular column, you will see that there are nines as well. So nine, basically if we come over here, there is one particular driver which is called as flight systems. So flight systems, what do you mean by flight systems? The flight systems basically are the control systems in the flight deck available for pilots and crew. Like if you have by chance or so, if you have seen the cockpit of the particular aircraft, because there are a lot of advanced controls actually available inside the aircraft. So basically you can say that like this is a big technological driver for us, because it involves a lot of safety as well. So the big aircrafts, you might have heard about the jumbo aircrafts called as A380, which were like double decker aircrafts. So these kind of aircrafts were equipped with modern technologies, really modern technologies. So like, because that also involves a lot of safety points, that you can actually evaluate a lot of danger beforehand itself. So basically these flight systems, which we can actually see over here as a driver, they have been actually been given a lot of weightage. So 9. And then you can similarly you can see other factors as well, like increasing demand for low cost transportation. Now every one of you would be thinking that, oh, okay, if we can actually get a one way flight from, say for example, from Ranchi to Delhi for 3,000 rupees, like but the thing is that like the flight has to be like, if you get the flight at that rate, basically you would need a low cost transportation. So how we can actually like have this kind of a driver? So this is basically has been given a weightage of 9. So therefore, like these are kind of big kind of drivers for the organization. Then again, we talk about production. Production also has like a very high rate, which is 8. So these kind of weightages that you see over here is not given by any random person, but there are experts who are sitting inside the organization. They are discussing what exactly would be the right driver for us, like how we can prioritize these kind of drivers inside. So these are our market and business drivers. Just give me a second. Yeah. So now you see over here, we actually talked about the market and business drivers, and now we come to the product features. So I will just shift back to the previous slide so that you do not get lost somewhere. So we were talking about the market and business driver identification, and now we jump to the product features. So these are all our product features. So say for example, one of our product features like that, we see what we can actually expect from our particular product. Like say for example, the A320, because we are talking about the single aisle aircraft. So one of the product features could be a better fuel efficiency. So so the current level that we see over in the product features is the Neo, which is the new engine option. So the new engine option basically is like you can say more fuel efficient engine. So that is the current level we are actually having. So before this new engine option, we had the CEO. Like the CEO was the older version, and now we have the Neo, which is the new engine option, and where we actually want to go. So like, so this particular chart will then actually tell you like where do we want to actually go, we where do you simply see yourself. So it is very simply like you go to a workshop and then you actually see that like, yeah, this is a product feature that we want from our aircraft, better fuel efficiency, but what do you want to have next, like what is your planning for the next particular product. So you would say that like, yeah, we need more fuel efficient engines. So basically then we will see that like, okay, so basically there is a gap between what we are actually having today and where we want to be. So this is a gap. So the gaps basically we can actually see that like the older aircrafts need retrofits. So what do we mean by retrofits? So retrofits could be like there is a part which basically has been quite old, now you need a new kind of a part which has to be replaced. So there were older aircraft which are actually having which were actually having older parts, and therefore you need retrofits over there. So new kinds of parts which are coming up. And then like again we can talk about different product features again, like you have parts design. What is the what do we have today? So like we have like large wingtips like sharklets. If you have, why do we call it as sharklets? The thing is that like now if you see in on an aircraft, the blade or like the wing of the aircraft basically, it is tilted a little bit slightly. Earlier it used to be completely flat. Now we have like designs of the particular wings which are basically curved, like right at the end you will see some kind of a portion which is actually bent a bit, and that looks like the tail, or like if you have seen the upper portion of a shark basically in a movie or so, it is similar to that, it looks very similar to that, then therefore like it was named as sharklets. So there are large wing tips which are there for the design. And now where we want to be, like we want new wing designs for more fuel efficiency. So now we actually identified that like currently there is no there is no requirement as of such, like we do not know where exactly we want to go. So very honestly we have actually written that there is no gap actually existing between where we are today and where we want to be, but we have seen that like we need more collaboration with research institutes. So there are a lot of research institutes actually in Europe, and therefore like Airbus actually collaborates with these particular institutes to actually do a lot of research. So so basically you can see that like these are the gaps that we are identifying with different kinds of product features, say aircraft emissions, cabin layout, seating capacity, then maintenance manuals, structural material, and so on and so on. There are a lot of actually product features that we actually evaluated, and then we saw what is the current situation at the moment, and like where we actually want to be, and what is the gap basically means what is the difference between the current level and in the future level. That is what we see in the product features. So then again, what we also see is that I have also mentioned here what all are the short-term goals and the long-term goals. So the technology roadmap actually does not only connect the four different things such as market drivers, the product features, the technology features, and the resources, but it also gives you a planning. So like how you can actually move from one particular goal what you are having right now to 3-year goal, and then 7-year goal. So it is a kind of a planning tool as well. So similarly in your research as well, what you can actually see, if you are actually developing something or you are actually evaluating a new kind of a technology, you can use this particular tool where you can actually see what do we have exactly right now and how you can actually plan for the coming years with that particular technology or with that particular research. So this is and then you can combine with a lot of other technologies, how actually it is connected together. So this is what we actually identify over here. So say for example, if we were talking about fuel efficiency and we were seeing like what is the current level at the moment, such as new engine option, then we identify that like in 3 years that like we need a better combustion basically with a different engine blade design. So this is like a 3-year goal. Then in 7 years, what we see is that there will be a combination of electric and fuel powered engines. Now you have already heard about a lot of different organizations which are actually moving completely electric. Say for example the Tesla. We were talking about, we have been talking about this particular automobile company which is going full electric. Now we are talking about aircrafts as well currently, which will be actually be a combination of electric and fuel powered engine. So that basically would be like fuel efficient. Like you will be using like a system which basically relies less on like a very certain kind of a fuel. So then basically that would mean that like it will be of a lower cost maybe, and then it will cost you less at the end, because at the end like the customer is the person who should be happy at the end. So that is one particular thing which we can identify from this kind of an evaluation. So similarly we do it for all the other products. So yeah, when I was talking about like what is the matrix that we actually develop, this is the quality function deployment that you see over here. And what we do over here, as I was telling you when I was talking about those particular four different kinds of things, A, B, C, and D. So the A was basically the market drivers, the B was like the product features. So this basically, when we talk about like product features such as, say for example, better fuel efficiency, parts design, these are kind of your product features inside. So now here, like there is a small kind of a mistake, which is like it's mentioned technology features, but the thing is that like the core idea behind it is that like when you actually see this particular matrix, you have to evaluate these kind of different kinds of features such as better fuel efficiency, parts design, and you go on actually evaluating with different kinds of features on the left hand side. So you will place one particular market driver. Say for example, if we actually consider this as like a market driver on the left hand side, and these are the product features, so you will actually compare better fuel efficiency with every kind of a feature that you see over here. So say for example, composite primary structure. So you will actually compare this with better fuel efficiency, and then you will evaluate that, okay, does this particular composite primary structure have any effect with like better fuel efficiency? If basically the ranking is very low, like we will say that like, okay, yeah, there is a very low kind of a chance that like this particular feature, which is composite primary structure, has an effect on the better fuel efficiency, then we will name it as 1. Like we will say that like there is a low correlation. And then like we will also see that like what all are the what is basically the relation between composite primary structure with parts design. So we will actually go on doing this kind of evaluation. So it would be like, say for example here, you see 0 as well. 0 means like there is no correlation at all. 1 means there is a low correlation. Then you will see at some places there might be a 2 as well, like here. 2 means like there is a medium kind of a relation between them. And then there is 3, which is means like really really high correlation. That means like this particular thing, like this particular structural material and the relation between composite primary structure is really really high. So it's like 3. Then these particular weights that you see over here, where do these numbers actually come from? So these numbers are basically coming from here. Like these numbers that you saw over here on this part, like these weights that we saw, we do it for every particular driver. We will do it for market business driver, we will do it for product features, we will do it for technology features, we will do it for resources. So you will see over here that there are weights over here which we have copied from the previous slide, and then we multiply these particular numbers, 9 with 1, 7 with 1, 6 with 0, which basically is a 0. And then like when you sum this particular thing up, there is a total which is coming at the end. So this is a number. And then we will actually rank them. We will say that like, okay, so 45 is like he's having the highest number when we actually combine advanced turbofan with all the other features. So this advanced turbofan technology features becomes very very relevant for us because it is having the highest number. So we give it as a priority, like 1. And then you have system health monitoring diagnostics. What do we mean over here is like we are talking about the predictive maintenance part, like about the aircraft health. So there are a lot of technologies through which we basically can evaluate like if your aircraft is actually performing well. So then like this particular is 13 number is 38, we have 39 and 36. So we rank them accordingly, like according to the weights of them. and then therefore like we have actually marked them as green, because these all four are our top technology features. Because you will actually ask me that why do we not actually consider them as well, like say for example wireless in-flight entertainment, the landing gear. The thing is, you cannot have every kind of a feature inside the organization, because the problem is like every or other organization has a budget actually. So you cannot actually concentrate on each and everything. You need to have a prioritization. So this is what you can also say as a prioritization matrix as well. So yeah, we similarly like the product features. When we are talking about product features, similarly we do a technology feature analysis, and this is what something you were actually seeing over here. So these all are our technology features. So what kind of technology features are existing? What is the current level at the moment? Where do we actually want to go? Like if we just take just a simple example, like a composite primary structure. So we have a material which is called CFRP. So we have like the current level is actually CFRP at the moment, like carbon fiber reinforced P. I'm forgetting the part P, but it's like carbon fiber reinforced something like material in the market. But currently, what we have like but actually the aluminium is currently actually used. Where we actually want to go is like we want to have a combination of like titanium in combination with the CFRP. But what is the problem that we see over here is that like the cost is too high. So the thing is that when we were actually evaluating product features, we were doing a similar kind of an analysis. So what is the current level that we are having? Where do we actually want to go? And then we see the cost. Similarly for the other technology features as well. And then again, when we were actually talking about product features, we were doing a planning as well. Where do we want to see ourselves in 3 years? And then where do we want to see ourselves in 7 years? So these are kind of the things that we actually evaluate over here. So what is the current level? Where do we actually want to go in the coming years? So yeah, so I will just like go through this like very slowly. So let's say for example, we were talking about composite primary structures, smart wings. You have cabin lighting systems, wireless in-flight entertainment systems. We have advanced turbofan. We have the landing gear, and then we have 3D printing as well. I think like a lot of people would actually be talking about this as well, about 3D printing, because this is one of the current things which is actually ongoing. We are talking also about like 4D printing, so that's another thing. And then so this is what we have currently. So basically inside Airbus we are already using 3D printing to actually for wings. So the wings basically is a part which is actually manufactured in UK. So basically over there is a lot of research going on for 3D printing of the wings. Who knows, like in the near future we will be seeing an entire aircraft, the structural part at least of the aircraft being designed in the 3D printer. Who knows? And so basically in 3 years what we see is like these kind of things. Like in 3 years we want to see a topology, optimize small parts. Then we have hybrid deposition and machining for like in 7 years we can actually see. Then we will again like do a similar kind of a thing. Like again I would like to revisit that particular part when I was telling you that like we actually evaluate A with B with C, and again C with D. So this is second stage, which is like we are evaluating again our product features. If you remember, we actually did an evaluation already between market drivers and product features. Now we will again do a evaluation between product features and technology features. So we are slowly and steadily, we actually like we are actually doing an analysis like stage by stage. And then after this, like we will actually see what all are our resources inside. So what are our resources? What do I mean by resources? So resources could be anything. Like say for example that like, there are a lot of partnerships with subcontractors. So basically there is Alten, Altran, Safran. So all these three companies are also existing in India as well. So the thing is that like these, you can say that like this is one of our resources. So from these particular resources you can actually achieve a lot of things. Say for example, if you want to have partnerships with universities like TU Delft or Hamburg University of Technology, this is where I studied from. So like if you actually have partnerships with these kind of universities, there are a lot of research which actually goes on, and like they give you a lot of study about what is the aircraft emission, about the advanced materials and alternative fuel techniques. So therefore you can actually see what all are the resources, so how you can actually achieve these kind of technologies that we are actually talking about. So it's is that is what we actually deal with over here. For R&D, there is one particular robotics company which is actually called Kuka Robotics. It's a very famous company if you just Google it. And they actually give us services such as production optimization, 3D printing. Similarly, you have other partnership with other companies such as GE, Pratt and Whitney, and then Microsoft. And then like you have tie-ups with startups such as eFlight, Symposium, Stellar Technologies. So like these are all our different resources through which we actually derive the particular knowledge from different settings. And then you have also crowdsourcing. What it's a very famous term, a lot of study actually goes on, is that say for example you are going on any kind of a platform from where you are actually giving out some kind of knowledge. So say for example if you are going to this particular website, Science Direct, if you're going to Science Direct, and on Science Direct basically you are giving out your knowledge through a research paper. So these kind of research knowledge basically which is existing out there, they also derive this kind of a research knowledge out of those places. And say for example if you are having a kind of a customer complaint, like if you go to Indigo, you say that like, hey, we were having this kind of a problem inside the aircraft. So basically Airbus can also look into these kind of activities, and then they will understand that okay, the customer is having actually problem with the seating arrangement, and this particular feedback will actually roll back to the particular organization, and that is what is actually called as crowdsourcing. That means you are developing knowledge from the crowd basically, which is you. So then that basically services that means like we are actually using that particular knowledge for the passenger experience. So now what is basically this, like you must be thinking that like, okay, we talked about resources, we talked about what kind of service this particular resource is giving, but what is the technology? So as I told you that like every particular driver that we are actually using over here inside, we are naming it with some kind of a numbering convention. So for product, we were having P, we were having something else for the market driver. For technology, we have different. So say, for example, when we are talking about technologies, you might have seen now that like, say, for example, the composite primary structure, that is T1. For smart technology, smart wing technology, we have T2. So similarly, what we will see that like which kind of resource is associated with what kind of technology. So that way you can correlate that like, okay, which resources can actually contribute to which particular technology. So say for example if we have a partnership with university, and so basically it talks about technology T1 T2, so we will understand that okay, when we talk about T1, that means like we are talking about composite primary structure. When we are talking about T2, that means like the research institute is actually contributing to us with these particular technology features, with composite primary structure, with smart wing technology. So these are the technology with which it is getting evaluated. Now this one is a little bit hazy at the moment, but I can zoom a bit and then I can show it to you. Is that so if you see over here, this is the whole technology roadmap. So on this particular side, you see that like on the left hand side, you can see four different things. So these are the market drivers. You have the product features, the technology features, and then the resources. Remember, I told you that there are four different things inside, and these are all our four different things, like drivers, the product features, the technology, and the resources. And on top, you see the timeline. So it started from 2017 and it's going till 2024. So there is a planning as well. Like it starts from 2017, you add up 7 years because we were talking about short term and long term goals. So you have a timeline as well. So now you see over here what we have actually mentioned. So say for example, we had the drivers such as end customer experience, support for technicians. Similarly, we had like product features as well. So what all these are these red lines? So say for example, if someday you come to me and say that like, hey, like we want to actually increase our presence basically with more with respect to the end customer experience. So then what you will do is basically you will follow just this red line because we already developed this particular link. So say for example, if end customer experience is one of our priorities, we will actually follow this particular red line and we will arrive at less air friction. And like similarly, we will actually also consider the modified shape with smart materials. So this is a technology, these are the product features that we actually need to have over here. So this is somehow connected over here through the red lines. And then again you will say that like, okay, but how do we actually reach out these kind of product features with the technology available? So again, you will actually follow a red line again over on this particular side, and then you will actually consider these particular parts over here, like topology optimized small parts, hybrid deposition and machining. So these all are the technology features which can actually support you with this particular product feature. And then again, this particular technology, then again the question would be, what all are our resources to actually reach over here? Because okay, we talked about technology, but how do we reach to this particular technology? So then you will again we will again follow a similar red line from here on this side, and then we will actually come down to partnerships with universities. So that would be the universities. So this is how you actually combine everything right from the market drivers to what you are actually having inside the organization. So you first of all you so how did we actually begin? We actually began with our market drivers. We do the evaluation for it. We do the matrix evaluation, and after that matrix evaluation, we connect each and every dot inside. So that way, it gives us a very holistic idea about like how it is how we are actually maintaining this particular analysis, and how we can actually help the organization in reaching from these particular resources to these particular drivers. So what are we currently having inside our organization and how we can actually achieve them? So this is like, you can say, a very huge roadmap that we actually develop inside. So basically, what we can actually conclude over here is that currently there is like a very slow market. The market slowness is because like there are only two major aircraft manufacturers. So the theory behind this is like, when you have lesser amount of competitors existing in the world, then basically you will see a little bit of slowness. If you have more number of players, say for example in the customer side, you can see like there are a lot of players such as Indigo, SpiceJet. You have Air India as well, which are actually fighting for the market. But because of that, they are actually very fast with their customer service. Like they want to give you the most maximum amount of customer service. But the problem happens like when basically you have only two manufacturers, like which is basically Airbus and Boeing. So there is a sluggish market. And the customer demand, as I told you at the beginning, the customer demand for the single aircrafts has increased actually significantly. As I told you, like the population is increasing, the number of aircraft which are being demanded is also increasing, quite like is doubling basically. And then like this particular technology roadmaps helps you to actually identify your market and business requirements, and it aligns everything together with like the technology or the product features and the resources. So yeah, what could be the future work over here is like there are certain things which basically have not still been actually been discussed. Like some of the things, like say for example the risk and uncertainty analysis. So it is applicable to each and everything. A risk and uncertainty analysis, basically, like say for example we saw that in 2019 we started talking about COVID, and then in 2020 COVID actually kicked in. The COVID, basically it had a major impact on a lot of organizations. People were stranded in their places and they could not go to any other place. So basically, if we have certain kind of a risk analysis as well for these kind of things, like you can include some kind of a metric inside this particular planning for risk and certainty analysis, then actually somehow you can offset that particular result. Like uh, now we are using digital technologies to actually help us in doing our research, or like we can actually carry out our university classes. So that is a kind of a risk analysis that you already did, and then you brought out that particular technology and as a digital technology, and that is not now that is actually helping you out. If we did not have digital technologies, going to the universities, going to the classes would be impossible then. So basically that is a kind of a risk and uncertainty analysis that you do and try to offset that particular result by some kind of a technology. So these are like the future work that could be actually applicable to this roadmap as well. And So, and like there is also a possibility that many more brainstorming sessions which could be organized with different technology experts as well. Like we were talking about aircraft industries, but there might be a possibility that like if you bring in experts from the automotive side, that they will be also be able to give you a lot more perspective. So there is a future work which is actually possible. And like there the third point is like the big organizations like Airbus can actually use subcontracting services. Subcontractors basically like Alten, Altran, like these all are our subcontractors, and they also have a lot of knowledge. So if basically these people are actually brought into this analysis part, like this planning of technology roadmap, then these particular people can also help with their particular knowledge, because they have been serving these particular companies like Airbus for a very long amount of time. So they also bring in a lot of knowledge. So yeah, so this was from my end. So yeah, thank you so much. And if you have any questions, I would be very willing to take that up.
If any participant has any doubt or queries, then they can either write down in the chat box or raise their hands so that we can unmute you.
Yeah, Dhaneshwar sir has actually raised his hand.
Yeah, yeah.
Okay, Saurabh, nice to looking you for long period of time through that this Google Meet.
Ah, thank you, sir. Thank you so much. So basically, if people do not know what's my connection with Dhaneshwar sir, basically, so I did my first masters basically in Birla Institute of Technology, Meshra, and Dhaneshwar sir was my advisor for my master's thesis actually, and I had this subject called refrigeration and air conditioning as well. So he was my mentor as well, like inside the university. So I did a paper with him, and like my thesis basically, which was in the combined cycle power plant. So like that way, like we both know each other.
Okay,
Yes, sir.
Saurabh, one question I have here.
Yeah.
Like in aircraft, can we use the biofuels?
So there is a lot of actually research actually going on there as well. Like as I told you that like there is a lot of research going on in the electric part as well as the fuel part. So there is a lot of research going on how we can actually reduce this the fuel consumption, and and if we can have an alternative fuel somehow inside, because the aircraft fuel that we actually use inside our aircrafts is like very expensive, because they need to be of like really high quality. So there is a lot of research going on their end as well currently. But like more than the fuel part, I would say that like they are concentrating much more on the electric side currently. Yeah, so I would say yeah, so there is a lot of research actually going on.
Okay, thank
Oh,
you.
someone has, I think Mr. Rajiv has already written something like regarding India. If you can also say some words, maybe Mr. Rajiv, like that would be nice, like regarding research on that end, if you have some more knowledge, or because India is doing something as you wrote in the chat box. Okay, I think he's muted or. Okay, anyways. Uh, but any other questions or feedback?
Sir, it seems there are no more questions or queries. So,
Okay.
thank you so much, sir, for this knowledge pack session. We are overwhelmed to have you as our speaker. Sir,
Thank you
in
so
this
much.
session, you dealt various problems. Statements like adaptability to new technologies is very slow, as bringing a new kind of change in any new organization is very difficult. You also discussed why we need to increase the production ramp and focus on customer requirements. You discussed how we can use SWOT analysis, that is strengths, weaknesses, opportunities, and threats to analyze the business of an organization. Later, you also explained four types of workshops, that is market, product, technology, road mapping. Sir, I'm sure everyone got their respective glass of knowledge according to their thirst. Thank you, sir, again for sharing your insights and spending your valuable time among us. Thank you, sir.
Thank you so much. Thank you so
Okay,
much.
thank you, Saurabh, for nice
Thank you, sir.
presentation and disseminating your knowledge with the faculty members.
Thank you so much, sir. Thank you for giving me this opportunity. I'm very glad, and I would be really happy that like if somebody wants to have more amount of insights from this, or if somebody wants to discuss something about it. Thank you so much.
Sorry. As we have ended the technical session and have reached the end of this 5-day long faculty development program, so I would like to invite any of the participants. Please, one of you can share your views among the technical session or the faculty development program. Anyone, please? Uh, Kindly share your views with us. Okay, then a feedback form is provided in the chat box. All of you, please fill that feedback form. It is necessary. Kindly fill that feedback form. So now we will be starting the valedictory session. Okay. Then I would like to welcome our head of department, Dr. S.K. Singh sir, and our chief guest, Dean Academics, Dr. Pankaj Rai sir. With this, I would request our head of department, Dr. Sanjay Kumar Singh sir, to come forward and speak a few words on this last day of the program. Sir, please carry on.
Vanessa, I think sir is not here, so we can proceed forward.
Yeah, I think so. So proceed.
Yeah, we can now call Dhaneswar Mathur, sir. Okay, let's move forward. Now I would like to call Dhaneswar Mathur, sir, to give a speech and carry forward the valedictory session. Sir, please, can you proceed? Dhaneswar, sir.
Sir Dhaneshwar Mehta sir, please proceed with the valedictory.
Some network.
Okay,
Yeah, yeah.
Preeti.
Sir,
Hello.
Manisha.
yes, sir.
Actually, sir, Sanjay sir and the chief guest have not joined. Okay, so wait or delay some few minutes of this variety function.
Okay,
Okay.
sir.
Actually,
Yes.
Yes, sir. Sure. You will
so give some time for our HOD and this chief guest. In between, what
Okay.
you do, you can show some videos of the BIT scenery.
Yes, sir.
Yes, sir.
Actually,
And
what
all the
happened?
part.
Yeah, actually, what happened? Their session was 30 minutes of the discussion of this Kumar Saurabh, but nobody has asked him questions, so repeat it from. So
Okay.
give some delay, some 5 and 10 minutes. You announce it.
Yes, sir. Till then, all the participants are requested to fill the feedback form. It is in the chat box. Okay. And please fill it carefully as the mentioned details will be used in the certificates.
You can also share your views if you want on
Yeah, if
the
someone wants to share their views on the 5-day FDP program, they are welcome.
any one of you. Kindly share. Okay, then fill the feedback form, everyone.